Okay, good. How's it going?
I'm doing well, thank you. How are you?
Good, doing well too.
Right. Well, I guess we can go ahead and get started then. Thanks for joining on a Saturday.
No, yeah, thank you.
Looks like you are just starting your mock interviews.
Yeah, this is my second of 15, so I've got a long way to go, but just I'm taking the program kind of slowly.
Uh-huh.
Full-time job, and not in a hurry to change. Um, so yeah, kind of pacing myself and starting mock interviews now, reviewing technical material,
Mhm.
uh, and I'll do behavioral, I think, after a couple of these technical ones. So.
Yeah, definitely. It's good to not be in a kind of rush during these
Yeah.
very economic headwinds.
Mhm.
It's definitely a good thing to just hold still for now
Yeah.
and wait for these hiring freezes to blow over in the time being. So,
What's
if
your
it's all right
background?
with you, I'd like to evaluate you as a software engineer doing a regular data structures algorithms interview.
Cool.
Um, and then around like maybe 12:50, we can like do a quick review and see how we're at regarding that sort of baseline.
Yes, that sounds good.
Okay, cool. Well, let's hop into the CodeBunk editor. Do you have that page currently open?
No, I don't. Where should I find it? Oh, it's
Same
this.
place where you found
Oh,
this
got it.
Zoom link.
I see it.
Okay, and once you're in there, why don't you go ahead and share your screen of the editor within the Zoom window?
Yes. Um, Now you can see it, right?
Yep, I can see your screen now.
Awesome. Okay.
Cool. Now, at the top left corner, why don't you go ahead and pick the language of your choice?
Yep. Python 3.
Okay, and then hit the run button to see if the hello world is printing correctly. Perfect. All right. Let's go ahead and get started. This problem will be separated into a bunch of like separate tiers. So first tier should be let's try to get the naive part out at the very least and not spend too much time. Um, so let's say I am a cake eater and I want to eat cake, two cakes every 24 hours. Disregard sleeping. I'm just a cake eating machine here. Um, and I found all the bakeries in the area that sell cakes have a list of the time that they put out cakes for sale every day.
Mhm.
And I want to order at most one cake from each shop, but I also want to minimize time difference between uh, two cake purchases.
Mhm.
So my list includes time of each shop uh, selling their cakes. So when they put their cakes out for sale, and you can assume that they do that at the same time each day. We want to find the minimum uh, time in which I can buy two cakes. So here's my example here. Stop me if if you have any questions so far. If you just want to digest this question real quick.
This is good. I think just maybe you'll show this later, but how is time displayed? Is it like an integer or is
Yeah,
it
it's a great question.
string?
So as an example, Our time will be, well, it'll be constrained to each day. So for example, it'd be something like, this would be like 10 o'clock a.m. This would be 15, this would be something like 3:32 p.m. And then this would be something like 11:42 a.m.
And it's not given in chronological order?
No.
Okay.
And in this case, the answer would be 101 minutes. We want to return this as an int, so this would be, I'm just going to box what needs to be returned. And it's because 101 is the minimum time difference between all of these values.
I see. Okay. And that would be 101 because of the 10 o'clock and the 11:42?
Yes, sir, exactly.
Okay.
Oh, sorry, this should be 11:41.
Okay. Got it. Okay. Is that's the end of the problem statement?
Yes.
All right, and can we assume that the list we are given will have at least two entries?
2 entries.
Meaning 2 time slots? Like, could it, or would we ever be given a case where it's just 1 time slot or 0 time slots?
You can assume, yes, you can assume that there will be at least 2 cakes. But the thing is actually, if we have just one item in our list, then it means that that's the only cake in the area. That's the only bakery in the area. So we'll just buy 2 cakes there.
Oh, okay.
Wait, sorry. We can only buy at most 1 cake. So yeah, assume a minimum of 2 cakes.
Okay. Okay. Well, assume a minimum of 2 cakes. All right, and there are multiple bakeries, or it's a single bakery, but all the are all the bakeries displayed on the same list, or are there multiple lists?
No, you can assume that there'll just be 1 list.
Okay, 1 list.
But each index on the list will be a different bakery.
Oh, okay, got it. Okay. All right. All right. Let's see here. So I think a brute force approach would be to test all the combinations, right? So we could take for example, the value that's at the first index, and then see how much time elapses with every other available time slot. And so that would be fairly expensive. It'd be order of n factorial. And so let's see. So I think we can come up with something better. I'm thinking if we sort this list, then we could do that in order of n log n, and then we could do one more scan through the array and compare adjacent time slots and take the difference, and we keep the pair with the minimum difference. And so the scanning through it would be order of n, and so but given we need to sort beforehand, it would still be order of n log n. And so I think this would be a much more efficient algorithm than the brute force. Does that sound like a good approach to you?
Yeah, it sounds like a pretty good approach.
Okay. All right. Do you want me to start implementing, or
yep,
discuss the
sounds
algorithm?
good.
Okay. All right. Can I assume let's say this list is called times? Or what's it called, the input?
You can call it whatever you want.
All right. And for this, I'm just gonna, do you want me to create a function? Is that, let's say here's
Yes, please.
it's given times. Okay, and this should return the, what was it? Do you want the minimum? Yeah, 101. Okay. Okay. All right. So let's see here. First, I mean, one challenge that we have is that we're given times in a string format, and so we can't just like subtract to find out the difference. So I think it would make sense if we had a separate function to process that. So let's call process time, right? And so this is given a time as a string, right? And it'll return, I think an integer would be a simple approach where we can have minutes starting from midnight. And then that way with integers, it'll be fairly easy to compare times and sort as well. Now, I could either dive into how the main solver works, or if you want, I can and just assume we have this implemented.
Yeah,
Uh,
could you make an abstract function for now?
okay, just make it an abstract function. So let's say we have this in place. Let's look into the solver. Okay, so the first thing, I think it makes sense to pre-process all the times. So going through this, we'll need to iterate, and that'll be order of n time complexity. And so we'll just say for time in times, we want to process that time. And so this is going to return an integer. So we'll call this processed time. And we will make that replacement. So I'm actually going to change this to be enumerate times. That way we get an index as well, I. So we can then in place make that replacement. So for times, we insert this process time. So okay. Is this making sense so far?
So can you tell me what enumerate does?
Yeah. So enumerate when you provide a list or an array, and so it'll allow you to loop through that. So time will be each one of these integer strings,
Mhm.
and the I will be just an index. So it'll be however many times we loop through it. So it'll be 0, 1, 2, k up to n, n in this case. Does that make sense?
See.
So
Yeah, that makes
this
sense.
I allows us, the purpose of that is to slice times
Mhm.
at the correct index. That's all.
Okay, gotcha.
And so at the end of this loop, times will be a list of the same length, but just with integers representing the minutes since midnight. Okay. All right. So now we can continue with the rest of the algorithm. So like I said, we want to pre-sort the list. And so we can just to keep it clean, we can write a sorting algorithm, right? So sort, it's given times, and it'll return the same array. So just list. And we should probably dive into this. I'm guessing you want to see this implementation here. So, all right, so we could try out different sorting algorithms, probably merge sort or quick sort. Both are order of n log n on average. But if we want that guarantee in the worst case, then we need to use merge sort. And so we can do that. Okay, so let's do that. For merge sort, we want to provide a start and an end index. And so we'll initialize it by the start with the 0th index, the end with the last index, which will be the length of times -1. Okay, and we can do this recursively, and so we first need to define our base case. A base case would be if our start and end indexes are the same, then we don't do anything. We just return. Otherwise, we want to um, uh, divide and delegate, and then at the end we'll merge the solutions. So here for the divide step, we'll call sort recursively. We'll pass in times. The start will be the current start, and the end for the left half will be a middle index. And so here the middle will be start plus end minus start divided by 2. Okay, so, and then we'll call sort times from the middle, this time +1 because we want to, it's the right hand side. Okay. And here for the merge, we want to use an auxiliary array, and we're going to need 2 pointers, an I, which will sort the left hand solution, and a j, which will go through the right hand solution. So this will be made at +1. Okay. And so now we want to, let me think here. Okay, so while both of these are in range, so while I is less than or equal to its maximum value, which is mid, and while j is less than or equal to its maximum value, which will be end, then we want to go into this loop where we check if times at I is less than or equal to times at j. And if so, we append it to, we append I. Otherwise, if the j pointer was smaller, we append it first. So we append j. And here, since we append I, we also want to increment the pointer to go to the next iteration. Here we want to increment j. Okay, now it's possible that these two, the I and the j pointer, don't get to the end of the left and the right arrays at the same time. It's possible that one will get there before the other. And so in that case, we want to finish copying what's left over for that array. So if I is still less than mid, then we would go in here and just do this operation. Just copy the whole, everything that's in the left one. And similarly, we do the same for the right hand side, j. So equal to the what was it? And All right. Okay. So let me just go through sort once again to make sure it looks correct. So sort will be given times, a start and an end index. We'll check the base case, which will be when start and end are the same, in which case we don't do any sorting. We just return. Um, in other cases, we would calculate a middle point, which is the start plus n minus start divided by 2. Then we sort the left-hand side from start to middle, the right-hand side from middle plus 1 to end. Then we do the merge by creating an auxiliary array. We initialize the I and the j pointers. While both are in range, we do the comparison, append the smaller one. We increment I and j. We do the same if there's any remaining in the left array and the right array. Okay, I think this looks good.
Yeah,
So,
yeah, I think this looks really good too. Quick question though, what happens to aux after we finish running sort?
okay, thank you. Yes, I missed that part. We shouldn't be placing aux back into times. So times from start to end, and we want it to be inclusive. So we do a +1, and that way we copy aux back into times. Thanks for that. And that's merge sort. So going back to the solver, we've converted the times, we've pre-sorted, and now we want to do what the question's really asking us to do, which is do the comparison between the times and taking the minimum. So find min pair. And so in here we'll create a variable called smallest diff. We can initialize that to a large value, let's say more than the maximum it could be, or the maximum it could be, which would be 24 hours times 60 minutes. I guess, yeah, that is the maximum it could be. And so we want to loop through our times. So for let's call this j in range from. So since you mentioned the times will always have at least 2 elements, we can start by having we can start by having a pointer start at, instead of the 0th index, at the first index, and we can always compare that to its previous index, the one to the left. And so here the range will be, instead of from 0, it'll be from 1 to the end of our array, which will be times length of times. That's correct. Yeah. And here we calculate the diff, which will be times at j minus times at j minus 1. Okay. And then we check if this becomes the new smallest by comparing the min, getting the min between the existing smallest and this new diff. And then at the end, that is what we want to return. I see here you had it in an array, in a list. Do you want it that way, or do you just want the integer?
Array in a list. No, I just wanted to bracket it so that you don't have to return the word minutes as well.
Oh, I see. Okay.
But this looks good. Why don't you, given the example input, run me through this code, and just so that we can make things a little simpler. After we do run process time, the array will look like this. So this will be the time in minutes that gets returned.
Okay. Do you want me to? Oh, okay. You want me to assume this is what
Yeah. So like starting from right now, line 36.
Yeah.
Run through the code. So just to save you the enumerate part.
Yeah. So this is just temporarily. Do you want me to walk through it or like?
Yep.
Okay. Okay. So yeah. So this will be times, right? And so this array will be passed into the sort function. It'll check the length of time. So here, length of times is 3 minus 1 will be 2. So the start index will be 0. The end index will be 2. We step into the sort function. We'll check if these two are equivalent. They're not. And so, so yeah, we continue and we calculate the mid. The mid will be, so 2 minus 0 is 2 divided by 2 is 1 plus start, which is 0. So the middle point is 1. And we step in again recursively. I think this is maybe what you're getting at, is that this is kind of maybe unnecessary work. We don't need to step as far down as to the point where start and end are equivalent. I guess once start or the end minus the start is when that difference is less than or equal to 1, let's say, then we can return there's nothing to sort there. Is that what you're hinting at, or do you want me to just continue walking through the code?
Why don't we continue walking through here?
Okay, sure. All right. So yeah, again, so here mid was 1, start was 0. And so we step in recursively into sort. We go back. End minus start is, in this case, 1. Oh no, but let's see here. No, actually, I take this back. I think what I had before was correct. Start equals end. Okay, so going back to this, start is 0, end is 1. This is not yet equivalent, and so we again calculate the mid. The mid in that case will be 0, and so the start will be 0, the mid will be 0, and now we reach the base case, right? And so we return. And so we're back up one level in the stack trace. And so start was before it was 0, the end was 0. And so here the mid would have been 1, the end would have been, was it 1 as well? 1. Yeah. Yeah, exactly. So these two are base cases, right? So we return because we just have here. I'll just comment because it'll be easier to track where we're at. Start equal to 0 was the input, end equal to 1. Okay. So in this case, both just return, and then we want to merge the two. And so the I will be pointing to the 0, the J will be pointing to mid plus 1, which is 1. Okay. Since, let's see, the I is within range, 0. Yep. And J is also, yep. J is still within range. We do the comparison. So here, basically what we're comparing is the I and the J. So I being 0, J being 1. We're essentially comparing the 600 with a 932. Yeah, 932. Yep. And so in this case, the 600 is less than, and so we append that to the aux array. So aux starts to look like this. This was 600. And then so the next time around, I is no longer within range, and so we go into this loop to copy the remaining in J. So this is 932. And we copy that into times. So times looked like this before. I guess in this case, it looks the same way. Times 932. Does this make sense so far?
Yeah, I'm following you.
Okay. All right. So going back up one level in the stack trace for sort, we just did the one where it was 0 and 1. 0 and 1. So its parent would had to be so yeah, going back to basically the first time we call sort. Yeah, let's go back to that case. So right. So in that case, this was 0 and mid was 1, and that's everything we just did. And this is what we got out of that. In the next one, this would be the start here. Start would be 2, and the end would be 2. And so that's a base case, and so we return right. Okay. All right. Good. And so now we're ready to do the merge of this array right here with this other one, because this is already sorted. This is sorted as well within that array. Okay. And so here aux starts off like this. And we have the pointers I and J. So I'll just put this here. Yeah, I'll just put this down here for just to explain 1 second. So this is I is here, and J is all the way here at the 701. And so here we're both are in range. We take the minimum one, in this case 600, put it into the aux. And so we add in 600 since it's less than 701. And then so we move I forward, J stays where it was at. And here we do both are still in range, and so we still go in here. We do a comparison. J is less, and so here's where the sorting actually occurs. 701 gets added, and then we just so this falls out of range, and so we go into this while loop and finish copying everything that's in the left array. So 932, and so this is what aux would end up being, and we're putting that back into times. And so the in the main function, the solver function, what would come out of this is what we see here. This times would look like this. Does that make sense? Or
Yep, makes sense to me.
cool.
You can leave that comment open. I don't mind. Can you tell me what the space complexity of just the sort function will be?
Yeah, the space complexity will be order of n. That's because in merge sort we're creating basically a binary tree, and at every level in that tree we are basically during the merge process creating this auxiliary array that will be order of n. We'll have order of n elements, and then we add that back into times. So yeah, space complexity is order of n.
Okay, cool. And then can we run through the other part?
This one.
Yeah, the part you're highlighting.
Cool. Yeah. So here the max will be, I'm not sure what this comes out to, but a large number, right?
1440.
1440. And so J will start off at 1. And so we are comparing times at 1, which is this 701, and subtracting it from the previous one, which is this one. So here the diff is 101. And then the smallest diff, obviously, this diff is less than the smallest diff. And so this now becomes, this variable now becomes 101. And we go back around. So the next J will be 2. Diff will be the comparison between 932 and 701. So that is 231. And we do this min, and 101 is still less. And so that's ultimately what we return, 101.
Okay. Cool. And then once again, for a repeat, can you tell me what the final time complexity is?
Yes. So given that the bottleneck is the sorting process, the overall runtime complexity will be order of n log n.
Okay. And how do we do better?
How do we do better? So, I mean, I don't think we can do better in either one of these, and these are not bottlenecks, so I'm not concerned about that. I think for the sorting process, with a quick sort, we could save on space. Let me. It would still be time complexity would still be n log n. But yeah, we wouldn't need. We would have constant space, so that would be a way we could do it. The downside to quicksort is that it's unstable, but in this case, it doesn't matter because we're just comparing times, so it's not a problem. So yeah, I think that's one way we could improve it is by changing the sorting algorithm.
Okay. What if we didn't sort here? Is there another way that we can do slightly better?
Okay, let me see. Without sorting, I don't think so.
Here's a small hint here.
Okay.
And it's just for this business case, right? I am a cake eating machine. I only care about cake businesses. I'm not going to use this for anything else but cakes. And from the perspective of a cake business owner, I don't really care about the second in which I open my cake shop. Right? So even the most quirkiest cake business out there, their opening time is going to be like 11:41 or 3:32, but it won't be down to the second.
Mm-hmm. It's down to the minutes, right?
Yes, it's down to the minute. And if
Yeah.
we're able to be discrete in the minute,
Yeah. So I think um, we could implement a counting sort, I think. So there's only a limited number of values we could have within times, right? It's said it's 1440, the maximum number of minutes. Yep. So we could create an array that's 1440 long, right? We could scan through times once and keep a track of the number of times that a time is in the array. So it might be like this 10 o'clock, 1532. We increment the counts, and then we could use that information to then create another array which is sorted. And that way we could basically create this sorted array in order of n. So it would be actually n plus k being the 1440.
Mm-hmm.
So yeah, that would actually be a big improvement here.
Mm-hmm. That sounds good. Just curious, what would the n be?
The n.
The n in the complexity.
N plus k.
Yeah.
So in this example, the n is 3. So we need to
Okay. So n being the number of the size of times.
Correct. The size of times. So this n, and then k would be the 1440.
Okay. Is there any way we can just make it n?
Just n. Just n.
We only care about
We
the
don't have
time
to.
they open, right?
Yes.
We only have the opening time. We don't have the closing time here.
Okay.
So can we just find the index? 600, 932, 701, instead of iterating down the array.
Okay.
Then we just need to iterate through our array once. And no matter what, our array is going to be
I see. So
1440.
got it. So I mean, we could create a hash map where we loop through this, and we add basically our keys would be the number.
We don't need the hash map though, right? Just use a Boolean array or something like that, and then tick the index. That's the time, because our array is k sized.
Right. So we have an array of k size, which is the minutes. We loop through and basically flip, or we say that we have a true that we do have that time present.
Mm-hmm.
Oh, and then that's right. And then we loop through
like a sliding window or 2 pointers.
Yeah, where basically we have, oh, I see. So we have a pointer here and then another one finding the next one basically, and then taking the difference between the two gives us a time. Yeah, I suppose that works. And that would be order of n time complexity.
Yep.
I see. Wow,
you got it.
Awesome.
And then next follow-up question is, what if I'm being gluttonous and I want 3 cakes?
3 cakes. Okay. So
let's assume that we're doing it the array side, the linear time approach.
Mm-hmm. And what's subjective to minimize the total time between like
Yes.
Agree? Okay.
Yes.
So let's add in here a couple. So we could.
Can let you figure that out independently here.
Okay.
But a big hint would be to use a modulus to cover all the use cases.
Okay.
Cool. Well, that's all of the time we have today. So let's move on to the debrief here.
Okay.
In terms of complexity of the problem, could you tell me what the hardest part was for you?
Oh, not time complexity. You're saying like complexity to solve it?
Yeah. How difficult was this problem, in your opinion?
I think for me the last part, I don't think I honestly would have come up with the solution without your hints. So that was tricky. I think at first I was a little bit startled with into these being strings. But I guess it was helpful that we can assume this was a abstract function. But overall, I mean, just using what I was doing, the sorting part, like just merge sort, I think it wasn't too difficult. But obviously that's not the most optimal. So
yeah, definitely. And this question does hinge on the linear approach, but looking for the optimal one is definitely something that is also good to note as well.
Yeah. Do you think it was good or bad that I kind of suggested this first strategy and then did the implementation, or do you think I should have maybe dug out more information for what would have been the optimal to only implement that one?
It depends on the interviewer.
Okay.
If the interviewer stops you and says, "Hey, let's think of a more optimal solution," then think of a more optimal solution.
Okay.
In this case, I didn't really care whether or not what you had was optimal or not. So as long as we had some solution and then we're able to build on it, that'd be fine. Okay. What I don't want to see is the interviewer taking over and having the full what they want out, but then being too confusing for any sort of solution to be present. Right. So yeah, if we had additional time, maybe I would have asked for the linear time solution. But if not, we still have a good solution here. And this can be reviewed with hiring committee, and it can be evaluated with other interviewers as well. So always nice to have that.
Yes.
Another thing is, and I'm not too sure why, I see like this def keyword is red. Not sure why that is. So I don't know Python. I'm not too familiar with it, but if you can just like check to see what's up with that. Yeah, but it's all good if it doesn't compile. The Google code editor doesn't run any code. It's more or less a Google Doc. So don't worry about having it run or not run. Just get all the code out there. And then having like comments to substitute code if it's not part of the solution, like process time, perfectly fine.
Oh, okay.
Right. So this is good.
Okay.
make sure you optimize it. If you ever like make too many of these, because we only have one, right? If you make two or more, I would say put comments underneath it to kind of like remind yourself of what it does.
Yeah.
But if you just have one, it's fine to not have comments. That's just to help you not keep track of things during the interview, because you have a lot of stuff going on while you're answering the problems. These comments are great. I like how you have a bunch of comments to annotate the number, just to keep track of what you're looking at in terms of indexing, in terms of the values. This is good. Keep it up.
Okay.
And then also merge sort, quick sort. You have a very good understanding of different sorting paradigms. Just make sure that you also, if they ask you the pros and cons, that you have all of that on a cheat sheet beforehand, and you can just rattle them off.
Yes.
Because that's really good. I liked how you asked input questions, like what types of inputs am I going to get? That's good, and that you can that you ask for your own input and you're able to dissect the example clearly. Also good. Maybe if you have additional time, make up your own test cases and run through those to see if you can.
Yeah.
In this case, it's a little tedious. You have to convert string to int. So probably not the best thing for this example, but making up your own test cases and walking through whether or not it covers all cases, it helps the interviewer as well. That's part of the rubric. I can just write that down real quick. Part of rubric is there's first data structures algorithms. There's also test code. There's communication comprehension, and then ambiguity. This is like a subtopic, and coding. So these are the main rubrics that they would want to sort of base their evaluation on. So hit all these marks, and you'll be very well in the green zone.
Awesome. All right, cool. Thank you so much for all the inputs.
Yeah, no problem. Do you have any questions for me?
No, not at this time. Look into trying to solve this one.
All right. Well, before you leave, let me just send you the code, or not a code. Let me just send you the question.
Yes.
So that you can test the code yourself.
Awesome.
At a different time.
Yeah.
And yeah, that's all I have for you, man.
Cool. All right. Thank you. Appreciate it.
Yeah, no problem. Best of luck.
Thank you.
Bye.
Bye. Have a good weekend.
You too. Bye.